understand the meaning of the capacitance in the electrostatics. There is a conductor or a material where the charges are accumulated on the material or conductor. Of course, flux Q is the charge accumulated. In that state, the charge and the potential, that is, charge of the conductor and potential of the conductor, are directly related, direct proportion. Charge is directly proportional to potential of that conductor. More potential, more charge. More charge, more potential. This is a mathematical equation we can rewrite as Q equals C into V, where C stands for constant, the proportionality constant. This proportionality constant is called capacitance of this conductor. This equation we can rewrite as C is equal to Q by V. That means capacitance of the conductor is the ratio of the charge accumulated and the potential of the conductor. Charge accumulated by the potential. It says it is a capacity or capability or ability of the material or the conductor which stores up that charge, which accumulates the charge. What amount of charges the material can accommodate, that is called capacity. More charge, if it can accommodate, more capacitance. Less charge, less capacitance. That is why capacitance is defined in terms of the charge accumulated or charge stored up, that is static charge. Static charge stored up in that material divided by the potential. We estimate this value using 1 volt per potential, that is per volt. Per volt, what is the amount of charge accumulated? V is equal to 1, C equals Q. What amount of charge that the conductor can accommodate is called capacitance. Per volt, what amount of charge it accommodates, that is the capacity. It is a materialistic property. Different materials accommodate more, different materials accommodate, there is a different amount of charges per volt, maximum amount of charges. That is the capacitance of a conductor. So capacity means what is the maximum amount of static charge that material can store up is called capacitance. So this coulomb per volt is the unit of the capacitance. This is in short, that is farad, F. This is same as farad, F. This is the capacitance. Now, the conductor is taken in this fashion. This is only single conductor. If you have two different, that is two conductors, same material, same size, that is plate conductors, parallel plate. They are arranged in parallel fashion. So parallel plate, it is known as capacitor. This is a conductor. What is capacitor? Capacitor means two conductors are set or arranged in a parallel fashion. What is with a certain distance of separation in between them. So in between them you can take a vacuum, that is between them you can take either vacuum or any material, insulating material, non-conducting material. So it becomes a capacitor. So it is two conductors in this fashion. If that is the case, what is the capacitance of this capacitor? If you have a conductor like this and when you apply the potential using DC battery, when you apply the potential using DC battery, DC means direct current, what happens? The electric current flows in this direction, that is in the circuit like this here, and electric current flows in like this, but electric current will never flow from this point to this point because it is either vacuum or insulating material, will prevent the flow of electric current. So will make what is that? Will not make a circuit. But this battery, what happened to here conductor, when you apply the battery, charges are accumulated on the plate. That is a negative source, positive source. So this battery, what is that? Will make this plate accumulate with positive charge and this plate accumulate with minus charge. So my electrons are accumulated and positive charge or electron deficient positive charge accumulated on this conductor and minus charge is accumulated on this conductor, and these two are what is that? No electric current. So this accumulation increases till a limit. There is a limit for this capacitor. So beyond that limit, it will never get accumulated. That is the capacitance. So it has the capacity to accumulate some amount of plus charge and minus charge between these two plates separated by vacuum or any insulating material. It is called as a capacitor, and the capacitance of this device, we can use the same definition. The capacitance of this device, the device is two parallel plate conductors, is the same definition. Here the amount of charge accumulated, here plus charge minus charge. The surfaces, the surface area of this remains same, and the amount of charge accumulated here same as amount of charge accumulated. Here plus charge minus charge. So amount of charge accumulated either on this plate or this plate, and V potential in the space, that is called potential difference between these 2 points, between these 2 plates, delta V, and V as delta V. So the capacitance of the conductor, capacitance of this capacitor is Q divided by delta V. What is Q? Amount of charge accumulated on this or on this. This is called capacitance of the capacitor. This capacity or capability, it depends on what is that, what amount of charge accumulated with this potential difference. Now this is the one capacitance. We can write this mathematical equation, the capacitance, in terms of what is that, the measurable parameters, physical parameters, that is related to dimensions of these conductors. For this we have to go through these small derivations. This is the capacitor, electric field, here plus Q minus Q, that is a 2-dimensional surface, that is inner surface, that is surfaces are, the surface areas are same. The electric field, these are always perpendicular to the surface and perpendicular to this surface, and here plus Q, the electric field is away from the surface. Here minus Q, electric field is towards the surface. But you know what is that? This line is always perpendicular to the surface. Perpendicular to the surface, electric field. As you know, this the electric field is, that is a definition, rate of change of potential with the distance. That is rate of change of potential with distance. It is a definition, mathematical definition or differential equation for the electric field in the space, like the space between these two parallel plates. You can rewrite this as this: dV is equal to E dVr, and write the integral of this equation. The integral of this is dV equals delta V, that is potential difference between these two, is equal to E into dr is distance of separation between these two, that is integral values, integral function. So r is the distance of separation between the two plates, and V, the rate means delta V is the potential difference between these two plates. So replace this by ER, equation becomes this. So this is the electric field between the two plates. So we can estimate the electric field using Gauss theorem. As you know, if it is an enclosure like this, I can take this or this surface to estimate what is the electric field. So above I can take same amount of charge, same surface area, same amount of charge, same surface area, but difference is different signs we have, plus and minus. So according to Gauss theorem, assume that is an enclosure. The electric flux means electric field intensity into total surface area, either this or this. This is the direction of the electric field. Away from this way or away from the surface towards the surface, but perpendicular. The line is perpendicular to this surface, this surface. So this electric flux is equal to this electric intensity in the surface area of this or this, both are same, is equal to amount of charge this is accumulated, either this or this, divided by epsilon naught, according to Gauss theorem. Q divided by epsilon naught. That is, we call that Gauss theorem. So E is equal to Q divided by this. So in this equation, substitute for E, that is E evaluated using Gauss theorem, they are applied in between the two plates. Now this is E. Simplify, Q cancels. This is goes to numerator. Epsilon naught A divided by R. C. So capacitance is the usual definition. Here capacitance in terms of dimensions of this parallel plate. So epsilon naught into area divided by R. What is A? Surface area, that is inner surface area of this plate or this plate. Both are same. And R is the distance of separation between these two. Look at that. The capacitance of the capacitor depends on the surface area of the plate, any one of the plate. Both are same. Higher, that is higher the area, that is larger the area, higher the capacitance. Here, smaller the distance of separation, larger the capacitance. That is why in designing the capacitor, we always keep the distance of separation as smallest as possible to increase the capacitance, and the area of the plate more. That is one. So it is not only depending on this, it is also depending on the permittivity. That is, E epsilon naught is for vacuum. To take vacuum, it is a permittivity. If you use some other material, insulating material, that is with the high dielectric constant, high permittivity. So high permittivity means high dielectric constant material. So we can increase the capacitance. Capacitance is also depending on the material what we are used, insulating material. Insulating material of what is a higher permittivity or higher dielectric constant, it can increase the capacitance. So while designing the capacitor to have a more capacitance, we keep all these parameters in mind. The area of the plate and distance of separation and the material, dielectric constant of the material in between that, sandwich, that is The plates are sandwiched between what is that? The thin layer of insulating material. So that is we need these parameters to design the capacitance with more capacitance. So because this capacitance here, when this is capacitance, charges are accumulated. Static charges are accumulated when you apply the battery. Here when you remove the battery and put a load, what happens? If you put a load which can consume electricity, what is that? Here the charges, what is that? Here charge. Now undergo discharge. The charges, what is that? Undergo discharge with the flowing of electric current in the circuit. Take the load, you consume the electric current. So in that case, what is that? This capacitor, after charging, acts as a battery, source of battery itself. That is, this source is a electrostatic batteries. Electrostatic means there are what is that accumulators, battery with what is that chemical energy and electric energy, that is acid accumulators. But this capacitor has a source of battery, electrostatic capacitor. Energy stored as static charges. So these are used in circuits, electrical circuits as well as electronic circuits, as a source of battery to make what is a where there is requires more electric current or voltage to run, that is at that point. So that is the one we are using as a source of battery. So this is regarding the capacitance. And one more is a capacitance. So in number, that is the capacitance, number of capacitors like this. So many number of capacitors, we can combine them in two different fashions. That is one fashion in series combination. Other fashion, that is number of capacitors, 3 or 4 or 10 capacitors. Here number of capacitors in this fashion is parallel combination, it is series combination. If we do so, what is the net capacitance of this assembly? What is the net capacitance of this assembly? That we need to understand. So, if this series connected to a battery, that is DC battery, like this volt, and this network, what is that? This combination, that is a parallel plate, that is parallel capacitors, connected by a battery, like this, DC battery. So, what will happen here? Here, on each capacitor, same charge is accumulated, Q, but each capacitor will have different capacitance, different voltage, different potential, different capacitance, different potential, different capacitors, different potential. That we same in this connection. Here, in this connection, when you do so, what is that? Parallel. Each capacitor will have same potential. Look at the difference. In this fashion, each capacitance will acquire same charge. Here, each capacitor will have same potential, but different charge, different capacitance. Different charge, different capacitance. Different charge, different capacitance. So, in this fashion, that is voltage is potential. Net potential of this circuit is potential, overall potential or potential equivalent potential is equal to sum of all the potentials. There is a usual mathematical summation for this circuit. But here, the charge, different charge, different amount of charge. Total amount of charge in this fashion is equal to summation, sum of all the, that is net charge. Net charge of all the capacitors is equal to Q1 plus Q2 plus Q3. That is the one we can apply, the summation. So, with this summation, let us arrive the final equation, because using this derivation, C is equal to Q by V. So, write V in terms of this Q and C using this equation. So, the net potential, it is same as potential means Q by C. total charge remains same. Q by CE, that is capacitance is net capacitance. V means Q by C. Net means net. That is V1 means Q by C1. Q remains same, that is C1. Q by C2. Q by C3. Apply this formula for each one of these. And simplify, that is Q cancel. Take common factor, Q cancel. 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So we get this formula. Final, we arrive this, that's net capacitance for this fashion. Combination is this. This is a 1 over C1 reciprocal. Sum of the reciprocal of this is equal to reciprocal of the net capacitance. Similarly, when you do so here, simplification, this is the one summation. Write Q in terms of this definition is same. In terms of CV, here C1 voltage remains same. C1V, C2V, C3V. Here Q is equal to net means net capacitance of this fashion into V, same potential here. Simplify V is common factor. V cancel, remaining is C is equal to C1 plus C2 plus C3. That is here net capacitance is sum of the capacitances of all the capacitors. Look at the difference here. So in this fashion, the capacitance of this combination is always less than, decreases, less than this or this or this. The capacitance, the net capacitance of this combination decreases. By here, net capacitance of this will increase in this fashion. So if you have these combinations, because these two combinations, that is combination of this capacitance is more important in circuits, both what is that electrical circuits and also electronic circuits, where we in some cases we need to decrease the capacitance. We go for this combination, this kind of fashion of combination. Whenever the circuit needs increase of capacitance, maybe electrical circuits or electronic circuits, computers like this, so you go for this kind of what is that combination, more capacitance. So whenever we need a circuit of more capacitance, we use this. Whenever a circuit requires less capacitance, we use this. So this also both are finding applications in the electrical and electronic circuits. So this is the one. And having this, what is that? Here in a capacitor, in terms of energy I am talking about. This capacitance in terms of energy, that is potential energy, storing or work. Actually, when the battery is charging this capacitor, that is doing charging, your work is doing. You are doing work on this capacitor to increase the charge, because otherwise the plates are getting accumulated. You are adding charge, plus charge on this, minus charge on this. Addition of charge, what is that? Work is done. So you are doing work. Actually the battery will do work on this battery, that is to increase the charge. Applying this, increasing charge, adding charge. Work is done on this. Work done, work done by the external agency. That amount of work done, it will store up as a potential energy or energy of the capacitor. So the energy of the capacitor is equal to U, the potential energy, QV divided by 2. What is the Q means? What amount of charge that is accumulated, and the potential difference. That is a Q amount of work. QV divided by 2, mathematical definition. What amount of work is done is same as U, potential energy of the capacitor. So it is in terms of Q and V. It is in terms of Q and V. So we can rewrite this, what is that, in terms of only C and V. If we substitute for Q using the definition, this definition, Q is equal to CV. Q is equal to CV. So this becomes the U in terms of CV square by U. Substitute for Q, CV. It becomes C into V, CV square by 2. U in terms of CV Here U in terms of Q, there is a definition. You can write it in terms of this. You can also write in terms of what is that U in terms of only Q and C. So in that case, substitute for V. V is equal to Q by C. That is Q by C is equal to Q square by 2C. So U is the energy store, electric energy store, electrostatic energy store up in this capacitor. What amount of electric energy store up in this capacitor? It is either this or this or this. In terms of Q and V, in terms of C and V, in terms of Q and C. All are important to do the what is that solve the problems. So this is what is that regarding this. And one more, in the nature we also see the capacitor. What is a capacitor? During what is that rainy season, the lightning. During rainy season, the clouds and the earth. So clouds are also getting charge, positive charge. Earth is a negative charge usually. The charges are developed, electric charges develop because of friction between the clouds. But it's a plus charge. This keep what is that accumulating on the cloud. And here the earth is minus charge because of electrons, source of electrons. So these charges in between them, what is that air lies in between, atmospheric air, acts as an insulator. Air, insulator. So the charges are developed, the cloud and the earth is a natural capacitor. During rain season, the cloud forms what is that one conductor and earth forms another conductor. In between what is that air is a perfect what is that capacitor. So the charges increases upon increasing what is that limit. When the limit reaches, the charges will not accumulate. That doesn't mean that. Yeah, the charges what is that increases. That is capacitor means the charges go beyond what is that limit. If the accumulation of charges go beyond that limit, what happens? The insulating property of the atmospheric air, what is that, breaks down. That is becomes a conductor, change it to conductor. Therefore, the potential, what is the potential after that is called breakdown potential. Electric current flows with high voltage between the clouds and all. Yeah, that possibility is there. If the potential, what is that, charges accumulated is more than that, what is that, breakdown, the electric current flows. That is break the rule of insulator. That becomes breakdown potential. So that is the reason. So when the charges accumulate beyond the limit, the potential breakdown and the electric current pass through from the cloud into the earth. That is called lightning. Lightning of conductor. That is known as lightning. There is application, there is a natural application of the capacitor. With that, let us finish off the point of this. Thank you very much.